All right, what's up, guys? We're going to review the four triangle congruence theorems that you're going to see in LT7. They're sometimes also called postulates. They call them congruent proofs. So let's say we have two triangles here. I did my best to make them the same size. Of course, we're going to have to pretend a little bit that they're exactly the same. How could I prove that they're the same, though, without any information here? The first one we're going to talk about is side angle side. Okay, and it has to be in the same spot, right? So let's say I have A, B, C, and D, E, F. Okay, so I don't know if these triangles are congruent or not, right? That's our question. Are these two triangles congruent? Yes or no? Right now, I have no idea. I think they are. They look like they're the same shape and size. Okay, but until I have some of these symbols in there, then I'm not going to know for sure. So if I told you that this side and this side are the same size by giving them each one hash mark, okay, I have some more information. I'm getting closer. Now, what if I told you that this angle here is the same as this angle here? Okay, and they're in the same spot of the triangle, so it's the same side. Okay, so now if you told me that this side, if we measured it or something and figured out that this side and this side are also corresponding and congruent, now I have enough information to state that triangle ABC is congruent to triangle DEF. So I can put triangle ABC is congruent to triangle DEF. And the order of the letters do matter, right? If I named it A, B, C, then this one I have to name D, E, F in the same spot, same order. Okay, and how did I know that those two triangles were congruent? Because of the theorem side, angle, side. SAS. Okay, let's go to another one. So let's say once again I have two triangles. Okay, there's another theorem that says if you can tell me that all of their corresponding sides, corresponding means they're in the same place. If all three of their corresponding sides are congruent, meaning the same size, then these two triangles are also congruent. And the theorem that states that, or that we can use, would be side, side, side. So as you can see, as long as you have kind of three pieces of information, you can use the theorems, right? So we've went over side, angle, side. We've done side, side, side. Let's go with another one. Okay. Ooh, those are not that close, but we're pretending. Okay, so if I told you that this angle here is the same as this angle here, they're in the same location. And then I told you that this angle is the same as this angle. Okay, I have two angles, not enough information yet to say they're congruent. But then if I tell you that this side here is the same as this side here, I have another congruence theorem that proves that these are congruent, and that is angle, angle, side. As long as I have those three pieces of information in the same spot, I can use angle, angle, side. And notice the order doesn't matter. It was angle, angle, side, angle, angle, side. Okay, last one. Okay, let's do kind of a funny one here. Okay, two triangles. Okay, let's say they told me that this angle here is the same size as that angle there. And then they told me that this angle and this, side and this side are congruent. So right now I have an angle on the side and I have another angle on the side. I can almost say that these two triangles are the same shape and size. Okay, I just would need at least one more angle. These here in the center are called vertical angles. Vertical angles. Vertical angles are always congruent. They didn't even need to put it because vertical angles, it's almost like a part that you can use for a proof. Vertical angles are always congruent. So now I have the theorem angle, side, angle, which is another one. Angle, side, angle is another theorem. So we learned 4 congruence theorems. I do want to show you one more thing. I probably should have used it in one of the examples. Okay, this one here, let's say I gave you this angle is congruent to this angle. This is 90 degrees, so this also is 90 degrees. So right now I have an angle and an angle. This line here in the center, okay, these two triangles share it. So, then obviously they're going to be the same size because they're the same line. Okay, this line is the same size as this line, and that is called the reflexive property. Reflexive property. Reflexive property just says the same line is the same size as the same line. All right, guys, that should get you pretty much almost through LT7.